Okay, hope everyone's doing good at home. We're getting ready to collect our initial data for the dissolved oxygen content of our fish tank here. And what we're going to do is just see how much oxygen is currently in this ecosystem right now. And then we are going to set up a whole bunch of BOD bottles with different things in them to see like what the normal amount of productivity is in this ecosystem. And then we're going to add fertilizer to the ecosystem as well to see if that affects the oxygen content after we incubate it on the plant card after probably about 5 days. So let's first just get familiar with some of these chemicals that we're going to use. We're going to do like what's called a Winkler titration, and that allows us to look at how much dissolved oxygen is in a water source. So we have magnesium sulfate, that's our pink solution right here. This clear solution for the Winkler titration, this is this alkaline iodine solution. We're also going to need to use really concentrated 6 molar sulfuric acid, so that's why I'm all PP'd up. And then I made a starch solution right here. And then this is sodium thiosulfate. And you can kind of notice here, it kind of looks like a burette, but it looks like a syringe. So it's a syringe, it's graduated, but it also has the stopcock on it like you would have when you would actually titrate. And that way I can turn a syringe into a burette, and it's just a lot easier for us to use. So we're going to use these 4 chemicals right here. The other thing that I have is a bunch of fertilizer, and that's what we're going to put into our BOD bottles to see the effect of adding those additional nutrients to this ecosystem's water. So the first thing that we need to do is just figure out how much oxygen is in this ecosystem to begin with. And that process takes some time. So what I'm going to do is just take a test tube, and I'm just taking some of my aquarium water, and I filled my test tube up. And what I need to do now is I have dissolved oxygen in this test tube. And I just put the stopper on it because I don't want any of that oxygen to escape. I don't want to add any air bubbles to it. I'm going to add a little bit more just to make sure there's no air bubbles in there. And it's filled all the way to the top with water. That oxygen is dissolved. Dissolved oxygen tends to come out of water, so I want to fix it, meaning that I want to change that oxygen from a gas into something that's soluble, into some type of precipitate. So I'm going to take my first Winkler solution, number 1. I'm going to add 6 drops of that Winkler solution 1 to my water. And then here's my alkaline iodine solution, my Winkler solution 2. I'm adding 6 drops into that too. And then hopefully what you can see already, and I'm going to stopper it because I don't want any of that oxygen to escape. And even overflowed a little bit. But you can see the color has changed, and if I look closely, it looks cloudy. I can see this precipitate is already formed. I'm just going to put my thumb over it to hold it tightly, and I'm just going to invert it a couple times because I want to make sure that those 2 solutions are well mixed. And I'm going to let this test tube just sit for about 10 minutes because I want all this precipitate just to settle. And I want it to settle till it gets to be about halfway down the test tube. So while that settles, we're going to do some other things. We're going to kind of set up our experiment. I'm going to put that to the side. Now what I'm going to do, I have a whole bunch of BOD bottles. This one I've labeled respiration. This is going to measure how much oxygen is going to be used in a normal condition, so it's going to measure the respiration of just the algae. Here I have my NPP bottle. This one will measure net primary productivity. And then I have different bottles labeled with 10 milliliters of fertilizer, 20, 40 milliliters of fertilizer, and 60 milliliters of fertilizer. So what I'm going to do to each of these is add some algae. And here's my algae solution. It's actually leftover syndesmos algae that we used in our last photosynthesis investigation. So I released the algae from those beads that we had before. I debeaded those, and now I have a whole bunch of unicellular algae right here. So I'm just going to go through and add 10 mils of algae to each of these bottles, because I want each of these bottles to have the same amount of algae. Normally, if this was a normal aquatic ecosystem, I would know that it would have algae in there already. So this wouldn't be something that I would normally do if I was doing a pond or a stream. But I have a whole bunch of snails in here, and the snails eat all of the algae in my fish tank, and they are doing a really good job. I never clean that fish tank. The snails do a really good job, and I'm afraid that they've eaten all of the algae in this fish tank, and just to make sure that we get results, I wanted to make sure that we could seed this ecosystem with some algae to get us started, because I'm afraid that those snails are depleting that aquarium of all its natural algae. Alright, so these are all set. I have 10 milliliters of algae in all of my BOD bottles. The next thing I'm going to do is I'm just going to prep the rest of my bottles. The nice thing with this respiration bottle, all I'm going to do is fill it up with some water from my tank. And I'm filling it all the way up. And I'm going to hold it over the sink, because when I put the stopper in, some of this water is going to overflow, and that's what I want it to do. That now has made an airtight seal. There's water overflowing over the lid. That shows me that no water can escape. And because I want this just to measure the respiration of the algae, I'm going to cover it in foil, because I don't want this algae doing photosynthesis. All I want these algae to do is respiration. So it's covered with foil. That's going to be my respiration bottle. This one is just going to measure the normal net primary productivity of my water with my algae in here. And remember, net primary productivity is how much photosynthesis is happening after respiration is occurring. So I'm just saying, normal conditions for these algae, how that's going to change my oxygen level. That one's done. The rest of these, though, these all have different amounts of fertilizer in here. So I'm going to add 10 milliliters of fertilizer, 20, 40, and 60 mils of fertilizer to all of these. And remember that we are adding fertilizer to these bottles because we are simulating increasing the nutrient load from these commercial fertilizers, and we are modeling what would happen if these amounts of fertilizer came into our aquatic ecosystem due to runoff. So that's 10 mils of fertilizer, 20 mils of fertilizer, this is 20. I want 40 in here, so I'm going to add some more. And then here's finally my last one. I want 60 mils of fertilizer in this one. This is going to have a ton of fertilizer in it. Works better if I take the cap off. Okay, here's our 60 mils of fertilizer. So these are now all set. They have algae in them, they have fertilizer in it, and now I'm just going to add my aquarium water. Notice that I'm filling all of them up to the lid. It overflows. I don't have any air bubbles in here. So I want to trap all of that oxygen in these BOD bottles. These are all set. What I will do now is put these bottles on the plant cart, and they will just stay under the lights until next week, and we'll see how the oxygen levels change over the course of 5 days. is all set up, what I need to do now is come back to this test tube, because it has been about 10 minutes, perfect timing. And I want you to notice, see how that precipitate has settled? It's not taking up the whole test tube. I'm just bringing up my instructions. So what we're going to do now, we're going to titrate to see how much dissolved oxygen in our fish tank to begin with. And this is going to be our initial amount of dissolved oxygen for all of our bottles because it came from the same water source all at the same time. So, first thing that I'm going to do, I'm going to remove this stopper. I'm going to add 6 drops of concentrated 6 molar sulfuric acid. Actually, I think I have 6 molar and I need 18. So I will be right back. I'm going to get the 18 concentrated sulfuric acid. I will be right back. Alright, I'm back. The sulfuric acid that I had before was 6 molar. I need concentrated sulfuric acid, so this is really dangerous. This is 18 molar. And I'm adding 6 drops of this sulfuric acid to my sample. 1, 2, 4, 5, 6. Next thing that I'm going to do, I'm going to measure out 20 milliliters of our top solution free from our precipitate. So, that transferred pipettes all done. 20 milliliters of our top of our precipitate. And if you look here, like, you can see that that sulfuric acid has even caused that precipitate to fall quite a bit, and now it's much clearer. And I'm going to try to gather as much as this as I can without getting any of this precipitate in it. You can notice I'm being a little more precise with these measurements. I was measuring out the fertilizer. I didn't care if I was off a little bit, but since I'm titrating, I'm trying to be a lot more precise here. I'm going to put that to the side. Here's 20 mils. What I'm going to do now, I'm going to remove this tray. And I have some white paper because then I'm going to be able to see the color change a little bit easier. going to put this 20 mils into my Erlenmeyer flask. You can kind of see the color, a little yellowy tinge to it right now. And just so you know, like I'm looking to see like how much I'm going to titrate. I'm starting off with 10 milliliters of sodium thiosulfate. So that's how much is in my like syringe burette. What I'm looking at here is sometimes there's like other pollutants in here that I would start titrating with the sodium thiosulfate until I got this pale yellow color, but I'm already at this pale yellow color, so I'm not going to titrate at all because I already have that nice yellow color. So what I'm going to do now is I'm going to add my indicator, which is going to be my starch. And hopefully when I put the starch in, you're going to see this color change. I'm going to add 6 drops of my starch solution. And you can see that there. I have a nice like bluish color, kind of purpley. So what I'm going to do now is I'm going to titrate until I get a nice clear color. And then I will be done. However much I titrate, that's how many part per million oxygen I have in this sample. So I'm going to go ahead and open up the stopcock, and then I can really slowly regulate drop by drop. How much I'm adding to the sample. I'm swirling just to make sure that everything's really well mixed as I add my sodium thiosulfate. Getting close. Still a little bit purple. And that looks good. There's my endpoint. It's nice and clear. I am all done. And looking here now, I started out at 10 milliliters and I'm down to 8.4. So I started off at 10, I've titrated down, now I have 8.4 milliliters of sodium thiosulfate in here right now. So that's it, that is my titration. That's going to be, if I subtract that, that's going to be how much oxygen is currently in this habitat.